NASA has released an updated image of 3I Atlas, and it reveals one of the strangest anomalies we've ever observed. The photo captures a jet of material shooting out from the interstellar comet at a direction that completely defies known comet physics. Not toward the sun, not away from it, but at a right angle that shouldn't be possible if natural forces were in control. This unexpected discovery has scientists scratching their heads and wondering whether this object might be hiding something far more complex than a typical wandering chunk of ice. To understand why this is so unsettling, we need to trace the journey of 3I Atlas from the moment it was detected. This strange object, the third interstellar visitor ever observed, traveled from the direction of the constellation Hercules on a long hyperbolic orbit that proves it is not bound to our sun. Most comets, born in our own cosmic backyard, carry predictable physics with them. They glow and jet due to the sun's influence alone. But 3I Atlas has refused to play by those familiar rules. As it approached, ground-based telescopes and the Hubble Space Telescope captured something eyebrow-raising: a plume of material pointing in the direction the comet was traveling, toward the sun. Some astronomers dismissed this as unusual, but not unthinkable. Maybe solar heating was activating a region on the comet's surface that happened to tilt in an unexpected direction. We have seen rotational oddities before, so the anomaly was noted but filed away as one of nature's quirks. Then came October 2nd. On that date, 3I Atlas passed Mars at a distance of roughly 29 million kilometers, a close flyby by planetary science standards. Riding in orbit above Mars is the Mars Reconnaissance Orbiter, home to HiRISE, a camera so detailed it can spot objects the size of a desk on the Martian surface. If you wanted eyes with clarity enough to catch something subtle on a rapidly moving interstellar traveler, you could hardly pick a better tool. For over a month, researchers waited as the images were transmitted, decoded, and processed. Now those frames have been studied, compared, and rotated into a three-dimensional understanding. What they show is not merely a better view of the sun-facing structure already seen from Earth. Instead, the side-on perspective reveals a second jet, a long, thin, highly collimated feature emerging at a 90-degree angle to the direction of the sun's energy. That is where the confusion begins. Comets are governed by simple physics. The sun heats pockets of frozen material, which sublimate, turning from solid ice directly into gas, and erupt outward like tiny natural thrusters. Solar radiation pressure then pushes dust particles away from the sun, which is why comet tails always stream into the darkness behind them. Meanwhile, the solar wind, a high-velocity flow of charged particles, does the same to gas, stretching it into a glowing single direction that nearly always points straight away from the sun. Every force that shapes a comet's activity, without exception, originates from our star. Even rotation, which can move jets across the surface over hours or days, still obeys the solar influence. There simply isn't another dominant energy source out there within this region of space. So a jet pointing sideways, not toward, not away, but perpendicular, is not only strange, according to everything we understand about cometary physics, it should not exist.
Perhaps, someone might suggest, the rotation of Atlas is fooling our eyes. After all, comets spin. If an energetic region vents gas while the nucleus rotates, that jet appears to sweep in an arc, potentially giving the illusion of exotic orientation. But this possibility collapses when we examine the object's rotation rate. Atlas spins every 16 hours. Any jet created by rotation should form a curled, spiraling trail, just like water from a spinning garden sprinkler. The plume would curve, it would wobble. It would leave behind a shape that clearly reflects motion over time. Instead, we see a straight lance of material, collimated and unwavering across thousands of miles. It is behaving like a directed flow, almost like a rocket plume. For such a jet to remain locked perfectly perpendicular while the nucleus rotates, the vent would have to remain constantly pointed in the same cosmic orientation, which makes no geometric sense for an object tumbling through space unless something is adjusting it in real time. That is the argument brought forward by astrophysicist Avi Loeb, whose name became widely associated with the controversy surrounding Oumuamua. Loeb has long maintained that we must remain open to the possibility that not all interstellar objects are mere inert debris wandering through the galaxy. Some might be engineered. Some might be controlled. Some might even be probes, designed to survive unimaginable distances and quietly gather data as they pass from one star system to the next. He argues that the behavior of Atlas's perpendicular jet fits with the idea of an active mechanism, a propulsion system, or a stabilization system that fights solar forces rather than passively surrendering to them. Loeb has not claimed proof, only that the hypothesis is not irrational. When nature refuses to match our expectation, we must consider every explanation honestly. Others in the scientific community take a more conservative stance. They accept that the perpendicular jet is extraordinary but prefer to believe a natural explanation exists, one we have simply not discovered yet. Comets are famously diverse. The solar system has thrown countless surprises at astronomers, from double-lobed nuclei to outbursts that defy predictions. Back in 1994, the fragments of Shoemaker Love U 9 smashed into Jupiter after splitting apart in a tidal disruption event, leaving plumes and tails that were complex but still obedient to the sun. Hale-Bopp, one of the brightest comets in living memory, spouted multiple jets from different active regions as it rotated. Even Borisov, the first confirmed interstellar comet, behaved more or less like a traditional icy body from our own Oort cloud. All of them, every one, still maintained a relationship with the sun's dominance. So what makes Atlas different? If this is simply another comet, its behavior demands an updated understanding of cometary physics. We'd need to identify a fourth external force, or a previously undocumented internal phenomenon, one strong enough to overpower solar radiation pressure and the solar wind simultaneously. That would change more than just this single mystery object. It would reshape part of astrophysics. But if that explanation never materializes, if every test continues to point toward an anomaly without a natural cause, then the uncomfortable alternative becomes harder to dismiss. An object with self-generated thrust is no longer merely a comet. It is a vehicle. There is another layer that deepens this mystery. The viewing geometry in this case is exceptionally favorable. Many past suspected anomalies disappeared once we observed the same comet from a different angle. What looked bizarre from Earth flattened into something explainable when seen elsewhere in the solar system. But this time, the vantage point from Mars eliminates that excuse. HiRISE caught the scene from the side, while Earth observatories saw the front. Two entirely different lines of sight confirm the same geometry. It is not a trick of perspective. It is real.
NASA has not highlighted this anomaly in any official press materials. The public announcements have focused on the success of the imaging campaign, the rarity of observing an interstellar comet up close, and the benefits for understanding the composition of these travelers. Those details matter, but the question that draws the eye, the puzzle at the center of this discovery, has been left without acknowledgement. Some researchers believe NASA may be waiting for more data before making any definitive scientific comments. Others think the anomaly is being carefully reframed as interesting but not revolutionary to avoid public speculation escalating too quickly. But no matter how quietly the agencies speak, the images themselves speak boldly. Interstellar objects are time capsules from other star systems. They wander through the galaxy through millions or billions of years, carrying clues about places we have never seen. Oumuamua, the first one we noticed, showed no visible jets at all, yet it accelerated slightly as it departed, leading to speculation about non-gravitational propulsion. 2I Borisov arrived afterward, looking far more like a standard comet, but chemically unusual, with an unexpected amount of carbon monoxide. Now Atlas arrives and greets us with geometry that makes physicists uneasy. One anomaly can be dismissed, two can be debated, three demand a deeper look. In the months ahead, 3I Atlas will continue drifting farther from the sun's warmth, which means any natural jet activity should steadily fade. But if the perpendicular plume persists, if the structure remains sharp and directed, even as solar energy declines, then we may be forced to confront a remarkable possibility. We may be witnessing the operation of a technology not made on Earth, not born under our sun, but created in the orbit of some distant star we might never reach. Even if a natural explanation eventually emerges, and that remains possible, it will come from expanding the boundaries of cometary science. Either we discover a new category of physical behavior that defies our previous assumptions, or we open the door to the first evidence of extraterrestrial engineering. In both outcomes, our understanding of interstellar visitors will change permanently. The next time an object like this enters our system, we will know what to look for. We will point more cameras, we will gather more data, we will no longer assume that every icy wanderer is a simple relic of formation. Because one of them, this one, has already showed us that the universe can still surprise us in ways that challenge the imagination. When something from the stars crosses into our neighborhood and behaves as if responding to forces beyond the sun, we must not turn away. We must observe, investigate, and remain curious.
Whether this jet is a natural mechanism we have not yet understood or the quiet exhaust of a machine built far away, the message is the same. Our solar system is not isolated. It is a waypoint, a crossroads, a place where objects from other suns can drift in and leave behind mysteries that demand answers. 3I Atlas is already fading into the distance, accelerating outward on its unbound path. We do not know if it will return. We do not know what systems it will pass next. But for a brief moment, this visitor revealed something utterly confounding. And that glimpse challenges us to rethink our place in the universe. If we are not alone in the galaxy, then someday, somewhere, communication will occur. But before we can speak to whatever intelligence may be out there, we must first learn to listen. And sometimes, the first whisper does not come in the form of a signal. Sometimes, it arrives disguised as a jet, pointing sideways into the dark.